208 participants in this meet, and we are streaming. So your stage is yours. So please.
Easy way how.
Yep, sorry, just a second.
Yeah, we have some problem with audio and everything. But...
So we have some pieces that we already recorded because some of our participants in the FabLab couldn't be present right now. And so we're playing around with already recorded pieces and live ones. So just give me a heads up if the audio is on when we switch to the next piece. Go ahead with
the let me check. Can you hear us? Can you hear the audio?
No.
No, at least me.
Okay. Okay, we will solve that. In the meantime, just give me a second.
Take it easy. It's no problem. It's even for us. It's very challenging because more than 850 people registered, and we are not able to offer to all possibility to participate. So we open live streaming. So we are also learning from this and having some experience from this and preparing for next year, of course. And I hope our teachers will be they will understand that we are working on this. So as I said on the beginning, instead of give up and wait for next year, we decide to make something even better or extended version for this year. Until we are waiting for Trieste, just to say that možda na hrvatskom, da su kolege iz Trsta bili prošle godine na STEM tjednu uživo i pokazali nam mnoštvo interesantnih stvari. Nadamo se da će stvari proraditi sa njihove strane. Okay, I just told on creation that you were our guest last year on STEM week and show what you are doing in Trieste. So,
okay, FabLab.
Yes, sorry. Okay, here we are in the scientific FabLab of ICTP, and we are managing this FabLab that has a focus especially on science and education, and it uses all the usual FabLab technologies like 3D printing, laser cutter, CNC machining, especially for science and education, as I told you. And we are also organizer of the local Maker Fair Trieste, that is another event gathering inventors, makers, creative people, also educators, and it's very much involved in dissemination of science and technology. We prepared a couple of short videos to show you what you can do with those technologies, and hopefully we will be able to show you those videos. And then we are here to also give you examples and answer to questions about those technologies. So first thing we will do is we are now sharing our screen.
Entire screen.
Yes. Yes. Devi farlo su preferenze di sistema. Yes, just a second. You can still hear us, I hope.
Yes.
Okay. Give us a few seconds to be able to Firefox. Okay. Yes. No. Okay. Don't worry. I will. The only problem is that will be the audio. I hope the audio will be good, but give us a second to test the beginning of the video. It's the first time we are doing this on this platform, so sorry for that. Okay. No, va bene, lascia non fare screen sharing. Okay. So this will be the video. Sorry for the what you are seeing now. Okay, let me start from the beginning. So this is okay, but you don't have any audio, I guess. You can still hear me, but you cannot hear the video, right?
Yes.
So just a second. It will take.
We'll do a voiceover, no problem.
Yes, we will do a voiceover probably.
Se mi fai ripartire Firefox, lo risfaccio solo.
Apologize to Carl and Gaia, but unfortunately, as I said, we are a small non-profit organization, and we don't have money for Zoom to pay Zoom for consulting. So
the fault is ours, not yours.
Yes, yes, yes. we will be able to do it in a second.
Ma basta che fai partire l'audio forte, ci siamo.
Okay. Okay.
There you go.
Okay, there you go.
And we work at the FabLab, International Center for Theoretical Physics in Trieste, Italy. We wanted to show you some of the possibilities that a FabLab has to offer to schools using their appliances and their machines, or also a version of these kinds of techniques that can be used directly in the schools without having this kind of possibilities. The first thing we want to talk to you about is 3D printing. So let's move towards the printers. A selection of different kinds of 3D printers. One of them is working right now, as you can see. The process is very simple. We start from a roll of plastic. We have different kinds of plastic that we can use. The one that is more commonly used is PLA, and it comes from different kinds of starch from plants and so on, and then it's not polluting and doesn't get off any kind of smell and fumes that can be harmful or not that nice to have in a room. So here the object is being built layer by layer. The plastic roll that you see on the side is fed through the machine, heated up in this point where the tip is, and it builds one layer after the other. Here you can see a selection of objects made with a 3D printer. They can be mathematical objects, useful also for teaching about geometry and so on, or also artistical objects like this one. But to understand in an easy way how 3D printing works and how the layers are stacked, we can also use the more simple to find cardboard.
In fact, another way to create 3D printing is by stacking layers of cardboard one onto another in order to create a 3D object. Here we have some examples which combine geography and cardboard. So basically, by creating the layers, you can build a 3D model. We started from a 3D model of the island, so we can choose 3D print or making layers. We can see here another example of icicles turned in the other way, turned by 90 degrees. So we created an artistic model. These models were created with a laser cutter, but we don't need necessarily to have one of those. In fact, we can print with a normal printer the layers. We can cut them with scissors and stack one layer onto another in order to create our model. So we can show you the procedure on how to get the 3D model. In order to get our 3D model, we use a free website which is called Touch Terrain. Here we can set our parameters and then choose to export the file. It is based on Google Maps, which means that we can choose any place of the world. So here we can download our zip file. Okay, so once we have the file, it is an STL file, which means we can choose whether to 3D print it or to slice it in order to make a cardboard model. The software that we use to create the isocurves or different layers is called Slicer for Fusion 360. It is a free software. Once we import the file, we can choose whether to create horizontal or vertical isocurves. In one case, we receive geographically correct 3D models. Otherwise, like we showed before, we can create vertical isocurves, which gives us an artistic model. So we can actually choose what we want to do. In case you are provided with a laser cutter, you can download the DXF file and cut the curves in order to make the model. Otherwise, the other option is to print on a piece of paper the PDF file and glue it on a cardboard, so you can by hand cut the layers and stack them in order to have a 3D model.
Here are the single slices that must then be glued. Be careful because you see the numbers will be stacked in this direction, as you can see here. And we are not obviously limited to making geographical objects with this technique, but we can build whatever we like, looking on the web for 3D files and using this kind of software to create the project.
Okay, here we are again. Sorry for the technical problem. We had to solve on the spot with some ingenuity, I will say. Okay, here we are again. Sorry, so you can see us again.
Okay.
So, was it possible to hear well? Okay, and see well. I hope this. We decided to record this video, so everyone will be able to rewatch it. We are going to publish it on YouTube and give it to you, and also add all the links to the software. We just finished today. We are very sorry, so the video is still very fresh. I would say we didn't have time to put it already on YouTube and put all the links, but it will be done. It will be done very, very soon. So if you have any question at the moment about those things, we are more than happy to listen to short question before moving to another topic.
We already saw that Roberto put one of the links in the chat. We put the other one, but if there is something to translate, I have no idea.
Okay, so it was a question about software, but as Carlos said, it will be already written. It will be written with the instructions and with the video. We're also recording this, and we will try to make also subtitles for this. And so, if there is no questions, maybe we can have questions on the end. So you can continue.
Absolutely.
Okay. Yes. So the second video we want to show you is also the last one. Then we will be live. Is another brief recording that we made today as well of 5 minutes about other tools, other devices that you can use for teaching science, and that we tested here in the FabLab. And if you have access to a FabLab nearby, or you ask the help of your friends in Zagreb or in other places in Croatia, and you have access to a laser cutter, it's very easy to do them. But even without having the laser cutter, you can build those devices as well by using normal tools. Just take more attention and a longer time to do it, but it's completely possible. It's doable. So we will do the same thing. So sorry for the audio. Give me a second to make everything ready for that. So the video will be there in a second. So here is the video. Okay. And I will start with the audio in a second again.
No sound.
Audio, okay, I see. I don't know why, but I see that there is no audio. Let's see. Okay, why this is without, I don't know, but I will discover in a second. Then speak. Oh, yeah, I know why. Can you hear now? No?
No.
Okay. So.
Subjects. We're talking now about laser cutters. Laser cutters are...
Yes, now we have the audio. Okay, just a second. I have to go back at the beginning. And start, sorry.
My name is Gaia. We're talking about how the technologies that are inside of FabLab, scientific FabLabs in this case, can be also useful for the schools to teach various STEM or STREAM subjects. We're talking now about laser cutters. Laser cutters are interesting appliances that can be used to cut various kinds of materials. We usually use wood or plastic, acrylic plastic. The plastic sheets can be cut in whatever size and shape we might need, and can be also layered and glued together to contain something. We have 3 examples of scientific props, let's say, that can be used in the schools and that can be created using a laser cutter, but can also be made using normal kinds of saws and so on to cut the pieces of plastic. This is a smaller version that just has 3 layers of acrylic plastic and inside some glycerin. When the light shines through it, underneath we can see projected on a surface how the light reacts. Passing through the glycerin, we can see how it behaves and how the various points create a lens projecting very interesting shapes on the floor. This can also be achieved if you find some kind of plastic transparent container that can be closed, as could be a bottle of water that must have a flat surface. So if you're able to find some kind of bottle in which you can put some glycerin, you can easily recreate this kind of experiment with almost no difficulties. Here we have a bigger version. So this is the bigger version that we made to fit on a table. The principle is absolutely the same. We've got 3 layers of plastic, 2 for the outside and 1 disc that is just for the border. They have been glued together using a specific kind of glue that is just for acrylic. And inside we've got the liquid glycerin. We need obviously a light source. We can use the sun if available, that is absolutely perfect. Otherwise, we need some kind of light source that is not too much diffused. So some kind of LED or even better, other kinds that are particularly focused lights. The liquid inside can have to be tilted afterwards, so it coats all the surface of the disc. And when we turn it upside down again, you can see the small lenses that form on the surface of the disc. And you can see how the light passing through these kinds of lenses forms these, reacts in this way on the surface.
My name is Carlo. I want to show you other application of laser cutter and transparent acrylic plastic to make exhibit and demonstration tools for physics. After seeing what we can do for optics with the caustic generator, I want to show you what you can do to demonstrate the behavior of crystals, how to make a crystal, how to understand the effects and properties of solid-state materials. In this case, we will use the same kind of structure that is made as a sandwich of acrylic plastic. Instead of having glycerin inside, we have metal balls. The stainless steel balls, usually used for bearings, that you can buy at a low cost in big quantities. Here we have more than 500 stainless steel balls, 4 millimeters of diameter. Those can simulate atoms or molecules of a solid compound. And we can see how the crystal lattice is created when a solid material cooled down and became solid after being liquid. By agitating our device, we can make it all the balls moving freely, especially if you put them in horizontal position, of course. And so they will simulate the behavior of a liquid or a melted metal, for example, where each atom is free to move in every direction, every position of space. But when you start to stop, when you don't move it again, let's say, after a while, all the balls will find a fixed position, and they will have a random position. This is the same behavior of a solid substance that is amorphous, but all very little crystalline structure, very little periodic position of particles. But if you start to agitate slightly again, what you see is that domain crystallization are created. So area of the surface where the molecules or atoms are in a periodic pattern. They repeat each other at the same distance from each other in a very constant way. But from one area to another, you have different angles of repetition and different patterns. So those are called crystallization domains, and we will see them very well if you use a light projection through our device.
This is another low-cost object that you can create and that easily depicts something that usually is not visible. And so it can give an idea to students of something that on a book is much less interactive. In this case, we used magnets. These are neodymium magnets, and they have all been placed in the same direction, so they repel each other. We've got 3 layers of acrylic plastic, as you can see, and a 4th piece that is used as a slide through it. When I apply a force to it, we can see the behavior of the magnet. Let's think that each magnet is a molecule of a gas. When there is no force applied, they can arrange themselves with the maximum distance from one to the other. But when I add a certain kind of force, I add a pressure, inside the volume decreases, and I have to add more and more pressure, so they have to stay nearer one another because they repel each other in this moment. When I release the force, there is no more pressure. They immediately come back to the beginning stage, and they have the maximum distance possible from one to the other.
Okay, here we are again. Again, sorry for movement of the camera and everything. We have to use the microphone of the video camera because and listen to the audio from the computer loudspeakers. But no, not a problem. I hope it was okay for you. Again, here now we can answer to questions related to the last topics, if you have any, or if you want to write on the chat, if you can write question, it's okay for us as well. So any possible question?
Obviously, the slicing software is not just limited to maps, but you can make any other kind of object you want, finding or on the web or creating any kind of 3D model. So in this way, just layering the pieces or creating a more complicated structure with also the part inside. It's a bit long to do by hand, obviously, but it can be interesting for kids also for having some fine detail cutting out and so on. So, can steel balls be used for cinematic projects, or are they too heavy?
Okay.
Steel balls.
Steel ball, yes, of course. We use the stainless steel balls. So they are okay. I mean, they are little one, 3 millimeter, 4 millimeter ones, not very big one. But if you scale it up, it can be even bigger. Probably very heavy at that point. But and you can demonstrate a lot of things. For example, I haven't told it on the video, but you can see the small holes in the pattern. Those are defects in the crystal. They happen in real life. I mean, real crystal metal, they have this type of defects, holes, lines, and domain interfaces. So it's a very realistic simulation, actually, that can be used for teaching how metals, how solid behaves.
Yes, the important thing is to have the correct size of the steel balls in comparison to the
Thickness.
width, the thickness of the plastic. Otherwise, they won't align perfectly, and so all the bit would be a.
Yes, but it's a very, very nice device for teaching, and especially the gas simulator one is very nice, because when you explain the law of perfect gas that give you the relationship between the volume, the pressure, and the amount of gas, the mass of the gas, number of molecules, pressure, temperature, that is a mean feed, and the volume, it's very, very easy to visualize that as you reduce the volume, the pressure increases, and things like that.
So there's another question: if it's possible to create a 3D model in SolidWorks and then slice it using the software. Yes, obviously. You're a little bit limited in the details because you work with pieces of cardboard or plastic, and so you're a little limited. But there are no issues. You just have an STL file to feed into the slicer. So I don't see other questions. We've got another short video, I think.
Yes, sorry. No.
No, okay. More than one?
Ti ga sutra kad dođeš, ako slučajno nisam u FabLabu, vrcneš me i idemo.
In the meantime that we are talking, I will show you images of the FabLab and experiments that we have here. So this is our place. We are more than willing to release additional information and more instructional video on, especially for teacher, on how to build devices. If you have access to FabLab technologies, it's more difficult for us to imagine what is available in every possible place. But if you have a contact with a FabLab, this is the best place to go to learn and discover how to make your own scientific demonstration devices. And I think it's very important also if you involve the students and the children in building their own things. So not just using and learning from something that is already made that can be bought in a shop, but make your own scientific demonstration experiments at school, in the classroom, together with them. For those purposes, maybe the easiest solution is 3D printer. A 3D printer is very cheap nowadays. It costs around maybe 200, 300 euro for a good 3D printer already. And it's much less expensive than laser cutters and other FabLab technology, and still can be used for a lot of interesting experiments. So 3D printer is probably the most effective devices that you can use. As you see here, we are showing you experiments that we made in the FabLab. This is a boat made with recycled plastic and other things. So we also teach how to be more sustainable, how to use and recycle material, plastic bottles, pieces of wood, metal, scrap metal, everything that can be reused. And this is another experiment of vibration, audio vibration, and we also try to see how we can improve in the visualization of experiment. This is an example of a 3D display. We want to be able to demonstrate three-dimensional effect using a special type of screens that can be cheaply made with a tablet and a mirror, or robotics. Here an example of a 3D printed robot, and also with cheap software you can use CNC machines to build small stuff, small objects that can be used for experiments. All those things you can learn in the FabLab, and this is something that we invite you to do as soon as you can. Be informed where is the nearest FabLab, or be the one that create a FabLab in your own school. You can start with a 3D printer, really, and became part of this big network of laboratories all around the world. As you see, we collaborate between Italy and Croatia, between Trieste and Zagreb with the FabLab, but there are many more FabLabs all around the world, and they are all willing to share knowledge and share capabilities together. So this is what we like to do. Okay.
If I just may add, following session is also from FabLab in Portugal. So FabLab is very open to especially for education. FabLabs are open for education. Sorry to interrupt you.
Oh, no. Well done. Well, perfect. Thank you. So now, Guy, I want to show you a few more things, maybe. I will explain you, and while he will show you. This is this will be something related more with art than science, but is also part of mathematics. So we go back here in our normal video screen. So some time ago, we wanted to explore how to teach beautiful mathematics to small children. And one possibility is to create a tessellation of the floor. So you have shapes, geometrical shapes, that can be used to cover a plane, to cover a floor, to cover a room. And instead of using the very simple type of tessellation that are called periodic tessellation, where you use square or hexagons or triangles to cover a floor, because it's quite boring after a while, we decided to use one of the latest discovery of mathematics, that is a non-periodic tessellation of the plane. So there are two shapes, and those two ones that you can see here, those two shapes, those are very special because adding these small details that forbid you to make some connection and allow you to make only other type of connection. So you can't connect those sides, but you can connect, for example, those other sides. Will force you to make a very special type of tessellation that is non-periodic. So there is no way to repeat this forever. You have to change shape every time. And it's a very nice game for children. If you can produce them, then you can just print the shape and cut by hand. Or you can make the laser cutter. They can play for hours and hours trying to make a pattern, and the pattern at a certain point will always fail. It has to be non-periodic. And so there is a mathematical demonstration, of course, and everything. So you can start to use those type of games. There are many possible games to teach mathematics in a very creative way. Especially mathematics is easy to visualize if you have a 3D printer, if you have a laser cutter, because you can make crazy geometrical shapes that are used to teach many things. A typical example we do is puzzles with three-dimensional pieces of plastic or fractals. This is an example of the puzzle that you can 3D print. It's a free model you find on the internet, and it's very easy because it's a pyramid with triangles as sides. But it takes some time to learn how to do it, because most of the time puzzles are just solved by pushing things. In this case, you have to rotate the two parts together in a very, unintuitive way. So before you learn how to make the puzzle, it takes minutes or even half hour. And children will learn that geometric shapes are important to discover, not something that is boring, but something that is very exciting. And you can also make a demonstration of things for say higher grades school, like non-conformal 3D shapes. This is Klein bottle, Mobius strip, other things like that. So our invite and suggestion is to try to get a 3D printer and start to imagine what you can do for your teaching. Because even if it's very simple, but when you can make something that children can touch, it may help them to understand the difficult concept. This is a fractal. Fractals are also interesting geometrical structure because they are in between dimensions. This is a three-dimensional object, but it feels the volume, but not like a three-dimensional thing. It's more like a 2.5 dimension things because it's mostly empty spaces. And to teach what a fractal is and how it behaves, a 3D printer is a very, very good tool because we can make them. That is, it's very difficult to make them with paper or on the screen only. So yes, this is our. I think there are other questions. No, there are just people that is saying thank you. Okay, we thank you all, and we hope it was interesting. What we wanted to show. Sorry for the technical issues, but for next time we will be more prepared. We hope that there will be no next time with virtual things. We will meet in person, like we met last year in Zagreb, and we hopefully do again in other parts of Croatia
and
as
in
well.
Zadar also.
Yes, we hope to see that you will be doing more and more events all around the country. As we try to do in Italy as well, but it's difficult here as well. So yeah.
And maybe some questions from audience, but until we don't have.
Okay. There are example.
Video instructions on how to make your own tools.
Yes. Okay. Well, most of the things we shown have been made by us with the laser cutter. But especially for the acrylic parts, you can cut acrylic also with a normal hand saw or with a mechanical saw. So it doesn't need to be a laser cutter. I mean, you just have a piece of acrylic or transparent plastic, and you can cut it polycarbonate. There are many types of plastic, very cheap ones as well. You can cut them. It will not be maybe as polite as a laser cut, but it will be cut by a saw. So no problem at all with that. Most of the experiments we are doing in the FabLab can be done maybe a little bit slower with normal tools. And with 3D printers, you can make tools. Because, for example, when you have a 3D printer, you can print the pieces to make another 3D printer or to make a small CNC. Or you can add a laser emitter to the printer so you can cut paper. All those things are possible at a low cost. So what is nice of maker technology is that most of those technology came from people that does it as a hobby, not as a profession. So they want to be cheap. They want to keep things at a low cost. And it is very often possible to even use recycled pieces of tools, motors you have around, pieces of electronics to build those devices. This is very important. The most important source of all the resources is the internet. We found ideas and drawings and instructions for all of those things in the internet. So feel free to explore and ask questions to us and others. Write to us, write to other FabLabs and ask them how you did this, how it's done this way. And so, because everyone is very happy to answer and share knowledge. This is the most important principle behind the FabLab is we want to share knowledge. We don't want to keep knowledge hidden or secret. We want to keep it as wide diffuse as possible.
Yeah, opposite to some entrepreneurial mindset, maker's mindset is much more shareable and share experience and share knowledge. We are always open to new ideas, and this also is some opportunity to extend this collaboration. Maybe we are interesting to build maybe some sources for schools and invite those 850 people who registered to check these resources and try to get something from this. So this is just a first step. As I said, Carlos said, of course, it will be great to be here in Zagreb or in Zadar, but for our guest, let's say next guest from Portugal, or tomorrow or day after tomorrow from USA, it's much problematic. At least to pay them. So this is a nice opportunity to have this version, extended version with a virtual presence, somehow at least explored for next year, so to have some other people who are not able to join, but of course to have this hands-on, because we are based all our activities on hands-on workshops. So try do something, not just listen or just thinking about or telling about, but just doing. It's very important, especially for the kids. But sorry for interrupt you again.
No, absolutely.
It was okay. We finished our demonstration, so we were ready for questions. We want to leave you with a message that is from Hamlet. Instead of thinking to be or not to be, you should always think to make or not to make. And the answer is yes, you have to make. Build your own stuff, because by building your own experimentations and devices and tools, you will learn much more than by just using them. And for children, it's important to give them this message. They have to learn how to build things for themselves, because nowadays we are surrounded by a technological world. Children, very especially, they use cellular phones, they use computers to play games, and they don't know how things work. But by building things by themselves, they learn how things work. They learn science, they learn technology, they learn all important things that will be useful for their lives. So to make or not to make, yes, to make. We have to learn how to make things.
Thanks.
So thank you for all of you.
Thanks for having us, and please keep in touch if you need any of the teachers have some questions, whatever. We are so very happy to help out.
I will take this opportunity in few maybe minutes. Maybe our friends from Benfica is already here to add maybe something.
Yeah.
Great.
Hello.
I want to thank you, but I want to thank our friends Carlo and Gaia, and of course Sara and other in scientific FabLab in Trieste, because you always here when we need you. And yes, what can I say? It will be great to have you in Zadar. I hope we will have you in Zadar in April next year. At least
Keep
to
up
have a good time. Okay, so if there is no questions, you can still stay here.
Be connected. Yes.
Yeah, and Andre. Hello, Andre.
Hello. How are you? Thank you very much.
We break the ice with 2 previous sessions, and so we are actually having 2 nice sessions. And thank you for respond to our request to join us, and it will be great. Just to maybe to introduce yourself and say something about your workshop. Just before you start, just to inform our audience, which is around 205 people right here on the meet, that Andre will take, we share a link, and he will take his workshop on another platform with a limited number. And so this is just